Let's now talk about how to gracefully shut down a service instance. When you're doing things like the first upgrade pattern where you're bringing down all the V1 instances and you're going to bring up the V2, or when you're doing a rolling upgrade and you bring down some V1s, bring up V2, bring down more V1s, bring up more V2s, and so on. In an ideal world, you would like to have your service instances shut themselves down in a graceful way. Because it's possible that you might have instances that are processing client requests, and you don't want the orchestrator to just kill those instances while they're in the middle of a processing client request. You would like the current client requests to complete processing. You'd like to not accept any new client requests, and then when you know the instance isn't doing anything, then it can go and bring itself down, right? That's ideal. Again, in this world where failure is always inevitable, you can never control when hardware just fails and maybe that instance was processing client requests. But for something like a upgrade that you're doing purposefully, we can do that in a graceful way to reduce causing any problems for clients' requests that are into your service. So let's talk about that, how we do this graceful shutdown. Well, we talked earlier about 12-factor applications or 12-factor services, and if you read more about them, you'll see that 12-factor services are typically stopped via a SIG term or on Windows Control-C. And your service code should go and intercept this SIG term or Control-C, and then you can perform the following operations. You want to drain any in-flight requests before stopping the process that your service instance is running in. The way that I do this is I use an integer representing the number of requests that are currently in flight. And when my process instance starts up, I initialize this to 1, not 0. Now you would naturally think 0 because initially when you first come up, you haven't received any client requests yet. But there's a reason why I do 1 and not 0, which I'll get to a little bit later on. Then as requests come into your service, I increment the integer. And then as requests leave the service or they complete, I then go and decrement the integer. By the way, this incrementing and decrementing has to be in a thread-safe atomic way. So I use interlocked increment and interlocked decrement operations when I'm writing this code. So now as more requests come in, the integer goes up. As requests leave, the integer goes down. But it will never get below 1 because you initialized it to 1. Then to stop, when you want your service to come down, you have to answer all future load balancer probes with a not ready response so that the load balancer will stop sending traffic. Earlier in the course, I talked about how the load balancer sends a probe about every 15 seconds. It's usually configurable, but 15 seconds is typical. And if your service is responding with HTTP 200 responses, then the load balancer will keep sending you traffic. But if you know you want your process instance to go down, then start responding to the load balancer with some other code instead of HTTP 200. Now the load balancer will stop sending you traffic. Of course, the load balancer probes every 15 seconds. So once you know you want to shut down, it might be that the load balancer had just probed you, so you have to wait at least 15 seconds for the next probe to come in before it sees that you're not going to return 200 anymore. And then you might want to wait a little bit more time than that because maybe there are some new incoming requests that are just coming now. So I tend to wait about 30 seconds after I know the process wants to shut down. I will tell the load balancer. I will then wait 30 seconds after that. Then, after that 30 seconds has completed, I decrement the integer one more time. So this is how the integer value will get all the way to 0. Right, it gets to 0 after I've told the load balancer I don't want to accept any more traffic, I've waited 30 seconds, and when I know that there are no more requests that are currently in flight within my process. Only then will I actually get to 0. And when that integer value hits 0, then the process can safely terminate and bring itself down. Right, so that's our graceful termination there. A thing of note here is you don't want to let a long-running in-flight request prevent the process shut down completely. Maybe some client request comes in and maybe it takes an hour to go and process that request. That's probably too long a period of time to prevent the rolling upgrade from actually running through. So if you're using containers, which we talked about earlier in the course, then the command that you use to stop a container is docker stop. And it has an option --time with an integer. And this integer specifies the number of seconds that Docker will wait before it goes and sends a sig kill command, which is, higher importance than the sig term. This will then force the process to die no matter what it's doing. Right? So that's not a graceful shutdown. So in other words, the sig term is initiating the graceful shutdown, and then some period of time until the shutdown completes. The sig kill is basically saying, we've waited too long, I don't want to wait anymore, and now I want this thing just killed. So this is a great way to give your customers a better experience when they're interoperating with your service, and it also allows you to perform upgrades on a regular fashion.